On January 8, 2026, a calm but urgent transmission from the International Space Station shattered the silence of space. The crew's voices, usually steady and composed, now carried a note of tension that was impossible to ignore. A SpaceX Crew 11 astronaut faced a serious medical emergency, one that could not be treated with the limited resources on board. The situation was dire, and the clock was ticking. For the first time in history, a crew would be evacuated early from the ISS, cutting their mission short in a race against time. Every second in space is meticulously planned, but the human body remains unpredictable, and emergencies can strike without warning. The 4 astronauts aboard Dragon Endeavour, NASA's Zena Cardman and Mike Finke, JAXA's Kimia Yui, and Roscosmos's Oleg Platonov, had spent 167 days in orbit, working together as a team, far from home. Suddenly, their mission changed. The new objective was clear: get one of their own home, and do it as quickly and safely as possible. The crew sprang into action, preparing for an emergency return. NASA's announcement triggered a global response. Around the world, experts and the public alike watched anxiously as the situation unfolded in real time. The return journey, a fiery plunge through the atmosphere, is always dangerous, but this time, the path was littered with new hazards, making the mission even more perilous. Thousands of satellites and debris now crowd low Earth orbit, creating a complex and hazardous environment for any returning spacecraft. NASA and SpaceX had to plot a safe corridor for Dragon, threading it through a dense field of technology and debris, where even a small miscalculation could be catastrophic. This wasn't just about dodging a few pieces of junk, it was about navigating a metropolis of satellites, each one a potential threat to the crew's survival. The largest obstacle was SpaceX's own Starlink constellation, a vast network of satellites directly in the way of the returning crew's path. The stage was set for an unprecedented orbital maneuver, requiring split-second timing and flawless coordination between ground teams and the crew. The world watched as a new kind of space emergency unfolded, holding its breath as humanity faced the unknown in the most challenging environment imaginable. Re-entry is a controlled fall, a breathtaking plunge through the upper layers of Earth's atmosphere at hypersonic speeds. It's one of the most dangerous phases of any mission, where the margin for error is razor-thin and every second counts. On January 14, 2026, Dragon Endeavour undocked from the ISS, beginning a tense 10.5-hour descent back to Earth, with the crew bracing for the unknown. Every thruster burn was precisely timed, each maneuver calculated to guide the capsule safely to its Pacific splashdown zone, hundreds of miles from land. The descent corridor had to be perfectly clear. Collision with even a marble-sized object could be catastrophic, instantly ending the mission and risking lives. Low Earth orbit is now crowded with satellites, debris, and defunct spacecraft, creating a hazardous gauntlet for any returning crew. The proliferation of mega-constellations like Starlink has transformed the orbital environment, filling it with thousands of fast-moving objects. The crew's path home was a narrow keyhole through a 3-dimensional traffic jam, demanding flawless coordination and constant vigilance. The very system designed to connect the world now threatened the safety of those returning to it, a paradox of modern spaceflight. The challenge was clear: mission control had to carve a safe path through the chaos, or risk disaster for the crew and the mission. By 2026, Starlink, SpaceX's ambitious global internet constellation, had grown to an astonishing fleet of over 4,400 satellites, circling the planet in a web of connectivity. These satellites form a dense, ever-shifting network in low Earth orbit, a region already crowded with vital assets like the International Space Station. With so many objects in motion, the sheer number of satellites makes close approaches not just possible, but statistically inevitable. Normally, sophisticated automated systems keep these satellites safely apart, quietly preventing disaster. But this was no routine event. The returning Dragon capsule's descent would slice directly through the densest part of Starlink's operational shells, a region teeming with satellites. It was like driving an ambulance through rush-hour traffic, except the traffic was moving at 28,000 kilometers per hour, and the stakes were life or death. The capsule's trajectory was locked in by physics. Only the satellites could maneuver out of the way. SpaceX engineers had to orchestrate the movement of thousands of satellites in real time, creating a temporary void in their digital network to clear a safe corridor. Nothing like this had ever been attempted at such scale. or under such urgent, high-stakes conditions. The safety of 4 astronauts, their lives hanging in the balance, depended on parting this digital sea with perfect precision. As the world watched, holding its breath, the outcome of this unprecedented maneuver would soon be revealed. Moving a satellite is a delicate ballet, performed by radio commands from the ground. Each Starlink satellite uses a Hall effect thruster, producing gentle but persistent thrust. Small burns, over time, can shift orbit significantly. Every maneuver consumes fuel and must be precisely calculated to avoid new collisions. With thousands of satellites, the complexity is staggering. A 3-dimensional chess game at hypersonic speed. SpaceX's autonomous system usually handles collision avoidance, but this time, it was overridden. The goal: clear the corridor for Dragon no matter what. Every move had to be perfect. The margin for error was 0. The fate of the crew depended on flawless execution. Once NASA confirmed the evacuation, the clock started ticking. Teams at NASA and SpaceX had less than a week to solve a logistical puzzle. NASA plotted Dragon's exact descent corridor, a 3-dimensional time-sensitive keep-out zone. SpaceX identified every Starlink satellite that could intersect with this path. Hundreds of satellites needed to be moved, each maneuver carefully choreographed. Simulations ran non-stop. Commands were uploaded to the fleet in hours, not weeks. As Dragon began its descent, Starlink satellites fired thrusters, shifting in real time. On January 15th, at 0841 UTC, Dragon splashed down safely off California. The crew was home thanks to the largest coordinated satellite traffic operation in history. Human ingenuity had prevailed. Why such extraordinary effort? Because in space, one collision can trigger disaster. The Kessler syndrome. A cascade of collisions creating a debris field that could trap humanity on Earth for generations. Each shattered satellite becomes thousands of new threats. The Crew 11 emergency was a stark reminder: the risk is real and growing. Starlink's size increases the stakes. Every satellite is a potential source of catastrophic debris. This was not routine management, but a brute force intervention for human safety. The tension between global connectivity and orbital safety is growing. We are walking a very fine line. Crew 11's safe return was a triumph of technology and teamwork. SpaceX proved that large-scale, dynamic satellite management is possible. This event sets a new precedent for collaboration between commercial and government space operators. But it's also a warning. As more mega constellations launch, the complexity and risk will only grow. The need for international regulations and shared traffic management is urgent. Our reliance on space-based systems is only increasing. Ensuring orbital sustainability is critical for astronauts and for life on Earth. A crisis in orbit could quickly become a crisis on the ground. The path forward demands wisdom, foresight, and shared stewardship of space. The future of our access to the cosmos depends on the choices we make now.